The majestic rise of mountains. Mountains are among Earth's most impressive natural features, but they didn't simply appear. Their formation is a slow, powerful process largely driven by plate tectonics, the theory explaining how the Earth's outer shell is divided into large pieces called plates. These plates aren't stationary. They constantly move, albeit very slowly, just centimeters per year. When these plates collide, immense pressure builds up. This collision can cause the land to buckle and fold upwards, creating towering mountain ranges like the Himalayas, formed by the Indian plate crashing into the Eurasian plate. The force is so great it can even push layers of rock upward over long distances. Not all mountains are created through direct collisions. Another key process is volcanism. When molten rock, called magma, rises to the Earth's surface and cools, it forms volcanic mountains like Mount Fuji in Japan or the volcanoes of Hawaii. These mountains often have a cone-shaped structure built up over many eruptions. A third way mountains form involves faulting, where cracks develop in the Earth's crust due to tension. Blocks of land can then be pushed upwards along these faults, creating steep cliffs and rugged peaks. Think of the Sierra Nevada range in California. These different processes result in vastly different mountain landscapes. The type of mountain form depends on how the plates interact. Fold mountains, like the Alps, are created by the compression forces of colliding plates, resulting in layers of rock bent into wave-like shapes. Fault block mountains arise from blocks of crust being lifted or dropped along faults. Finally, volcanic mountains are built up through repeated eruptions and lava flows. Understanding these distinctions helps geologists determine a mountain's history and the forces that shaped it. The materials composing the mountains also vary. Some are primarily granite, while others consist of sedimentary rock like limestone. However, formation is only part of the story. Once formed, mountains aren't permanent structures. Erosion, the gradual wearing away of rock by wind, water, and ice, constantly reshapes them. Glaciers carve out valleys, rivers cut through peaks, and rainfall slowly dissolves softer rocks. This process can take millions of years, but it eventually reduces even the highest mountains to smaller hills. The sediment created by erosion is then transported elsewhere, contributing to the formation of plains and deltas. In conclusion, mountain building is a complex interplay between powerful internal forces like plate tectonics and external forces like erosion. From the dramatic collision of plates creating fold mountains to the slow accumulation of volcanic material, each type of mountain tells a unique story about Earth's dynamic history. The ongoing process of erosion ensures that these majestic landscapes are constantly evolving, reminding us of the planet's continuous change over vast periods of time. Vocabulary list. Questions. Circle T if you think the statement is true based on the passage. Circle F if you think the statement is false. 1. Plate tectonics explains why Earth's outer shell is broken into several moving pieces. 2. Mountains are formed quickly, usually within a few years. 3. Volcanic mountains are created when magma cools and hardens on the Earth's surface. 4. Faulting occurs when plates slide past each other without any pressure being involved. 5. Fold mountains have a cone-shaped structure similar to volcanic mountains. 6. Erosion helps build up mountains by adding layers of rock. 7. Glaciers and rivers are examples of forces that cause erosion. 8. The Himalayas were formed due to the collision of the Indian and Eurasian plates. 9. All mountains are made up of the same types of rock, like granite. 10. Mountains remain unchanged over time. They stay exactly as they are formed.